Hi folks, so this is question 6. So part A asks us to differentiate by first principles. So first principles should look like this, not x. So when it's finished it should look like that. So the first thing we need to find out, so we know what f of x is since it's up there, so we need to to find out what f of x plus h is. So f of x plus h will be where you stick in a plus h beside each of the x's, so 2 x plus h squared plus 4 x plus h. Now I'm going to multiply out the x plus h squared in brackets here, so that's 2 times x plus h plus 4x plus 4h. So if we multiply out those double brackets, so you can use a grid or whatever if you want. We'll just leave the 2 outside for the minute. So x squared plus, so it's going to be plus xh, so plus 2hx, we'll put the h first, plus h squared plus 4x plus 4h. And then multiplying the 2, so 2x squared plus 4hx plus just 2h squared. And then plus 4x plus 4h. So it's getting quite complicated already. These always get complicated, but they're fairly routine. It's the same thing happens each time. Now we know what f of x plus h is, so we're going to go on to the next step and we're going to take away f of x from it. So f of x plus h minus f of x will look like all of that, what's there. So 2x squared plus 4hx plus 2h squared plus 4x plus 4h, but then we're going to subtract f of x from it. So f of x is 2x, so we're going to subtract minus 2x squared minus 4x, and then hopefully something will cancel out. Yeah, so we've got minus 2x squared and plus 2x squared, so they'll cancel each other out. And we've also got plus 4x and minus 4x, so they'll cancel each other out. So we'll just tidy that up for the minute. So we get 4hx plus 2h squared plus 4h, and then that's all that's there for now. Next step, if you look back up here at what we were at the start, you need to divide by h next, and then we'll put in the limit at the end. So next we're going to look for all of this, f of x plus h minus f of x all over h. So I'm going to divide everything then by h, so 4hx plus 2h squared plus 4h all over h, and then you'll see that the h in the first term will cancel, so we're left with 4x. The second term, one of the h's will go, so we're still left with plus 2h, and then the h in the last term will cancel out, so we're left with plus 4. And then the last thing we need to do is the limit, so limit of h tends to to 0. Fx plus h minus f of x over h. So the limit then means that this in the middle, this h in the middle will turn to 0, so we're just going to be left with I shouldn't have wrote it up there. we're just going to be left with 4x plus 4 as our answer. And then that works because if you just differentiate this as normal, so 2x squared plus 4x, you would just differentiate that, just drop down the power of x, it would turn into 4x and the first part, and then 4x would differentiate into plus 4. So that's what we got at the end when we did it by first principles. So it's fairly straightforward, but there's an awful lot of work kind of writing out in it, I suppose. Part B then, a rectangle is expanding in area, so a rectangle is getting bigger. Its width is x, so x an element of R, and x is greater than 0. Its length is always 4 times its width, okay? So find the rate of change of the area of the rectangle. Right, so let's let the length be 4x and the width be just x. So the width, or the length, is always 4 times the width, it tells us. So if the length is 4x and the width is just x, well then the area has to be 4x multiplied by x. So 4x multiplied by x is 4x squared. Right, so we need to find the rate of change of the area of the rectangle with respect to its width x when the area of the rectangle is 225. So if we let 4x squared be equal to 225, so let's divide by 4. So x squared equals 225 over, now I just noticed that 225 is a perfect square, and so is 4. So x will then be 15 over 2. So square root of 225 is 15, square root of 4 is 2. Then it's so it has to find out the rate of change of the area, so with respect to x. So we need to differentiate it then. So A, our area, is 4x squared. So we're going to differentiate it, and we're going to put in 15 over 2 instead of x. So dA dx then will be, well, it'll be 8x if you differentiate. So at any given time then it's going to be 8x. So let's sub in 15 over 2. So 8 times 15 over 2. It's going to be 4 times 15, so it's going to be 60. So that would be the rate of change then when the area of the rectangle is 225. Right, let's look at the last question. The graph of the cubic is shown. So the maximum value of p dash x in this domain is 1, and p dash 0 is minus 3, where p dash x is the derivative of p of x. Right, so they've given us the graph of y is p to the x, and then they want us, so we need to see what are the points that are on it. So so where it's 0, then minus 3, so 0 minus 3 has to be a point anyway, so we can put that one in. So 0 minus 3, so where p dash, so p dash x, where p dash of 0, it's minus 3. Right, what we need to realize is that because the graph turns here in both of these places, okay, that means that it has to be 0 there. Therefore, those are both roots at 1 and at 3. So that tells us that there's a point at 1 and a point at 3 because it has to be 0 there. Because the graph has to be 0 there. Or p dash x has to be 0 there. I think there's one other thing then about, so the maximum value of p to the x is 1. So if the maximum value of it is 1, well, if our graph goes through each of those points and it's going up through there, it has to reach 1 there. So is there one other thing then? So our graph has to look like that then. So we're just going to go through those points. You have to go pretty straight there. So our graph should look something like that.